going to talk today about the three main row operations and then how they work. So far in 8.1, we have the following skills. We can take a matrix and turn it back into a system. We can take a system and make it a matrix. We can use our calculator to put in a matrix and then do RREF, which is row reduced echelon form, and get the answer for any system. So those are the three skills that we have so far from 8.1. And now in the rest of 8.1 is all about the hard skills, the actual practice, the physical handwritten skills that we need to get, okay? And that's what we're going to do today. So we're going to focus on that. So to begin with, we're going to talk about the three row operations. There are three row operations. And these are operations. Oh, I forgot OPER. There we go. These operations can only be done to rows. Okay, I want to make that very, very clear. This is a row operation. This is not a column operation. We're not allowed to do things to columns. We can only do things to rows in matrices. Okay, so I'm going to give you the abbreviated version of what these things are. Okay, here's 1, here's 2, and here is 3. Doot, doot, and then doot. Okay, the first row operation we're allowed to do is we are allowed to swap rows. What does that mean? Swap rows. Yeah, like change them. Like if I want the third row to be the first one, I can just move it around. I can move the entire row to the first row or vice versa. So I'm allowed to swap any rows that I want to swap, okay? The second rule of row operations for matrices is that we are allowed to multiply any row by any number except, what do you guys think? 0. Yeah, we don't get that rule. We're not allowed to be like, it'd be great if this was a 0 here, so I'm just gonna multiply the whole thing by 0 and be done. No, unfortunately, we don't get that rule. But we can multiply any row by any number as long as it's not 0. Okay? So rule number 1, we can swap rows. Rule number 2, we can multiply any row by any number but not 0. And rule number 3 is we can add multiples of rows to other rows. Huh? What? This is the really fun one. This is the one that we use most often. Well, actually, we kind of use a combination of all three most often. So if I wanted to, basically, this just says that I could multiply row 1 by a 5 and then take the result and add that result to row number 3 and create a new row. That's what I'm allowed to do. So I'm allowed to add multiples of other rows to other rows. Does that make sense? It's kind of a weird rule, but you guys get it so far? So remember, we're doing everything by hand. This is the hard skill practice of section 8.1. We're doing everything by hand. So I'm going to show you how this works, okay? So I'm going to give you a matrix, and the matrix I'm going to give you is going to be this. Let's do 3. Let's do 18. Let's do negative 12. Let's do 21. Let's do 1, a 2, a negative 3, and then a 5. And then let's do negative 2, negative 3, 4, and 6. Okay? So, here is a matrix. What's the order of this matrix, by the way? There's a 3 by 4. It's 3 rows, 4 columns. Pretty straightforward. Okay, so let's do an example of how we show that we're going to swap 2 rows. Okay? So, here's what you can do. I teach this by doing all of the notation on the left-hand side of the matrix. Every book is a little bit different, okay? This is what I would want to do. If I wanted to swap row 1 for row 2, I would use these arrows to indicate I'm swapping row 1 for row 2, okay? Yes, question? Do you have to do that? Yeah, you have to do that. You have to put what you're doing to the matrix somewhere. Really? You do. Nope, you actually have to do it. This is what I call the roadmap of how to solve it, and yeah, it has to be done like this. Yeah. I'm just saying, we'll get to the why we want to do it later. I'm just showing you an example of what it looks like, okay? So if we did that, all right, it would look like this, okay? And leave some space to the left, it would look like this. 1, 2, negative 3, and then a 5. And then a 3, and 18, a negative 12, and a 21. A negative 2, a negative 3, a 4, and a 6. Okay, so that's what it would look like. So if I swapped row 1 for row 2, then I would get this. Now the book will make something like this. Row 1 and a double arrow, row 2, and it would probably put that over there. So you might see the book use that notation. I don't use that one for this one. I just use the arrows to say swap the two, okay? Then if I wanted to multiply row 2 by a third to make that leading entry a 1, I would say this would be 1/3 R2. So this tells the person who's looking at my work, which is going to be me for all of you guys, this tells me the step that you're doing to get the next part in the matrix, okay? So after doing that, I would end up with something that looks like this. I would not do anything to row 1, so 2, and then a -3, and then a 5. And then if I do a third of row 2, what's 1/3 of 3? That's just 1. What's 1/3 of 18? 6. What's 1/3 of -12? -4. What's 1/3 of 21? 7. And I do nothing to the bottom row. -2, -3, 4, and 6. So far, so good? So that's an example of, the second rule. Multiply any row by a non-zero number, okay? Let's do an example of the third rule of matrix row operations, which says that we can add a multiple of a row to another row. And here's what I would do. If, for example, I was interested in making this highlighted entry a 0, if I wanted to make that a 0, because we're going to get this into row echelon form and we want zeros right there. If I wanted to make that a 0, the way that I could do it would be this. I would say this would be -2 multiplied by row 1 and then added to row 3. So take a look at that notation. It says -2 times row 1 and then add to row 3. And notice where I'm putting it. I am putting the description of what I'm doing right to the left of the row that I'm going to change. Do you see that? Okay, and I did that with all of them. Notice that I put the description of what I am doing right to the left of the row I am changing. Yeah, this should be a regular too. Sorry. Positive too. Thank you. Thanks for seeing that. Okay, so let's see how this works. Again, I'm not doing, wrong pen. I'm not doing anything to row number 1 or number 2. So that's a 1, a 2, a -3, and a 5. A 1, a 6, a -4, and a 7. Okay, here we go. Yeah, this should have been a positive 2. Very good. So if I take 2 and I multiply it by the number 1, what do I get? Yeah, 2 times 1 is 2. And if I add that with -2, how much do I get? I get 0. Sweet. If I do 2 times 2, how much is that? That's 4. Then 4 plus a -3, that's 1. Okay, I do 2 times a -3. How much is that? -6. Add that to a 4. What do I get? -2. And then a 2 times a 5 is 10. And then add that with a 6, and you get 16. Was that a negative? Oh yeah, there we go. Nice. Okay, good. So there's an example of the 3 types of row operations that we've been doing that we can do. We swapped a row, we did a multiple of a row, and then we added a multiple of a row to another row. Okay, a little bit of history and clarification for you. What we're about to do is a method that's called Gaussian elimination with back substitution. That's the method that we are about to do, okay? So there are 2 methods here for solving these big matrices using this technique, okay? There is Gaussian elimination and then with the back substitution, which is what we're going to do. And this right here is taking a matrix and putting it into REF form, okay? So when you do Gaussian elimination with back substitution, that means that you're getting a matrix into row echelon form, which is something we studied yesterday, okay? The other way is something called Gaussian, Gauss-Jordan elimination. Okay? And Gauss-Jordan elimination is when you put a matrix into reduced row echelon form. Okay? So why am I telling you this? The directions in the book will say use Gaussian elimination with back substitution or Gauss-Jordan elimination. Okay? So what I, as your teacher, want you to do is this. Everything over here, this right here is calculator skills. Okay? That's the thickest blue you've ever seen. That right there is basically what I want you to be able to do in the calculator. This over here, is the hard skill I want you to be able to do by hand. Okay, so do you see the difference between the two?
Yeah.
So even though the directions tonight are going to say you can use either one, I want you to do it this way. On the quiz next week and on your final, I will give you one of each type of question. So basically, just like the quick start today we did in class, that's Gauss-Jordan elimination by putting a matrix into row echelon form. For those, you can just use the calculator, okay? But for us in this class, I want you to be able to do Gaussian elimination with back substitution, and that's the method I'm going to teach you right now, okay? You guys good? All right, sweet. All right, so what we're going to do now is we're going to do Gaussian elimination with back substitution, okay? So the first thing that we're going to do is we're going to take our system and we're going to turn it into a matrix, okay? So let's go ahead and turn it into an augmented matrix. I would have 2, 1, 2, 18. Okay? I would have 1, -1, 2, and 9. Then I would have 1, 2, -1, and 6. Did I do that correctly? Check, make sure I did it right. Okay. So I'm going to move this over just so now that this is what we're working with, okay? Here's what I would do if somebody asked me to say, hey, please use Gauss-Jordan elimination to solve this and show me how to do it. First thing I would do is I would actually just go get the answer, okay? I would want to know what the answer is, all right? And it turns out I plugged this into my calculator already. So if I do second matrix, I'll show you, okay? And I go over to edit, and I push enter. You'll see that this matrix is already entered. 2, 1, 2, 18, 1, -1, 2, and 9. A 1, a 2, a -1, and a 6. So I already have it entered in my calculator, right? No, you're just going to get this as the answer, okay? So we can just skip up to this. So I would take this information, I would plug it into the calculator, I would get my answer. And these are nice answers, so then I know if I'm doing it right, if I made a mistake along the way, okay? So what is the answer to this system? It's right there on the calculator. Can we read it? Yeah, x is worth what? 5. Y is worth what? 2, and z is worth what?
3.
Okay, so 5, 2, 3. I'm going to go ahead and write that down. I'm going to go write it down right over here. Okay? So the answer was 5, 2, 3. There we go. I won't forget it. There it is. There's the answer, and I'll come back to that in a second. Okay? I'll leave that there right there. Okay. Now, what's the goal of all this? Okay? Remember, Gauss, to put something into REF, reduced echelon or row echelon form, remember that our goal for our matrix is to look like this. We want a 1 here. We want something here, something here, something here. We want a 0 here, a 1 here, something here, something here. We want a 0 there, a 0 there, a 1 there, and then something there. Our goal is to make this look like this through those 3 row operations. That's our goal. So notice that we have 1s along the main diagonal, and then we have this triangle of 0s in the lower left. Everybody see that? Okay. Our goal is to make it look like that using those 3 row operations. And the secret is you want to start and get this position first. You want to definitely get this position first. And then get 0s below it. Once you have a 1 in row 1, column 1, and 0s in the rest of the column 1, then you move on to column 2 and get a 1 there and get a 0 below that. You do it in that order so that you don't undo what you've done along the way. And it took people a long time to really come up with that. So we're going to be very grateful for them. Thank you. So there's our goal. All right, so what do we want to do? Let's go ahead and apply this. I want this leading entry to be a 1. And I've got a couple of options for me, right? I could either multiply the whole row by a half, or I could just swap some rows. What do you guys want to do?
Swap.
Okay, some people want to swap, some people want to multiply by a half. For this purpose, let's all do the same thing. Let's just swap a row, okay? Which one do you want to swap? 1 for 2. Okay, now, you have to show me what you're doing. So this is what we've agreed to do. Okay, so below that, since I'm running out of space, I'm just going to go down lower here. Usually I would work to the left, but I'm running out of space. So if I swap those, I get this: 1, -1, 2, 9, Then I get 2, 1, 2, 18, 1, 2, negative 1, 6. Everybody cool with that part? Good. We've swapped row 1 for row 2. Okay, now that I have a leading 1 in this position, my next goal is to make this entry and that entry a 0. Okay? How do I make that a 0? Here's what we can do. Huh? You want it? Yeah, you want to get the 1 in the leading, you want to get this leading 1 and 0 is below it. Okay. We're going to do negative 2 times row 1 plus row 2. Okay? That's going to give me a 0 there. And then this one down here, we're going to do negative 1 times row 1 and add it to row 3. That's going to give me a 0 there. So how did I come up with that so fast? What did I look at? It's really simple to see. Yeah, but true, but there's something I'm looking at. What am I looking at? What did I do? I took the opposite sign of whatever the green highlighted number was, right? And then add them together. That's all you have to do. I took the opposite sign of the green highlighted number, and then that told me the directions to take. See that? Okay, so let's go ahead and do that, all right? And I'll use blue to keep it all consistent for you. And notice I can do two things, right? I can do two row operations in one sitting. That's allowed, okay? So row 1's not going to change. So 1, negative 1, 2, and then 9. Okay, now, negative 2 times 1, how much? Negative 2 times 1, how much? Negative 2. And then add that to 2. What do I get? I get a 0. Awesome, very good. Negative 2 times negative 1. 2. 2 plus 1. 2 plus 1's 3, I think. Okay? Negative 2 times 2. Negative 4 plus 2. Negative 2. Very good. Negative 2 times 9. Negative 18 plus 18. 0. Sweet. Awesome. Okay. Third row. Negative 1 times 1. Stay with me. Negative 1 times 1, everybody. Negative 1 plus 1. 0. Very good. Negative 1 times negative 1. 1. 1 plus 2. 3. Very good. Negative 1 times 2. Negative 2 plus a negative 1. Negative 3. Negative 1 times 9. Negative 9 plus a 6. Negative 3. Okay, good. We're doing great. I'm going to move this up. Okay. All right, look. We're doing great so far. Now I want that 3 to be a 1. What do I do? Yeah, multiply by a third. Great. Absolutely perfect. So I want 1/3 of row 2. Awesome. So I'm going to work sideways now to get that done, okay? Hey, hang in there. You guys are doing great. 1, negative 1, 2, and 9. This is going to be 0. This is going to be 1. This is going to be negative 2/3, and this is going to be a 0. Hold on. Keep going. We have 0. We have 3. We have negative 3. And we have negative 3. Okay. Hey, we know the answer is going to be nice. So there's light at the end of the tunnel. Okay. Look. Nah. Ouch. Jeez. Okay, look. That's a 1. We're doing well so far. Now we want what? No, we want this to be a 0. Okay, how do I make that a 0? Negative 3 times row 2, oops, and then add that to row 3. So negative 3 times row 2 plus row 3. That's my next move. I'll move over so we can all see it, okay? You guys are doing great. Stay, hang in there. Okay, so I got 1, negative 1, 2, and 9. I got 0, I got a 1, I got a negative 2/3, I got a 0. This is a 0, this is going to be a 0. Okay, so negative 3 times a negative 2/3. Oh, that's nice. That's just positive 2. What's 2 minus 3? Negative 1. Negative 1. And then negative 3 times 0 is 0, plus a negative 3 is a negative 3. Well, that's it. Hey, Josefa sees something. He's like, now just multiply this one by negative 1 row 3. I'll move over a little bit. And look what that gives us. That gives us this. 1, negative 1, 2, and 9. 0, 1, negative 2/3, and 0. 0, 0, 1, 3. Beautiful. Bada boom. What does this tell me right here? Z is equal to 3. And, hey, check it out. Remember, z was indeed equal to 3. Okay? So we did all of this right so far. And look, it's not that much. Look at what we've done. There's the whole problem from start to finish. Okay. Now remember, we have to actually go back now and get x and y, but this is where the back substitution takes place. So we don't need to keep going. We can stop the matrix operations. We just use back substitution. Okay? So I'm going to make this a little bigger and go ahead and use back substitution. What does this second line of algebra tell me? What does this tell me right here? Y minus 2/3 of whatever z is equal to 0. So y minus 2/3 of, but z was equal to 3, right? Is equal to 0. So that says that y minus 2 is equal to 0, so y is equal to 2. Hey, isn't that what we came up with over here? Check it out. There's the 2. All right. Okay, and then finally, what does this line of algebra tell me up at the top here? I'll do it in green for you. What's that tell me? That tells me that 1x minus a y plus 2, or is that a 2? Plus 2 z's is worth 9. That's a 2, right? Okay. So that tells me that y is worth 2, so x minus 2 plus 2 times z was worth how much? 3? Yep. Is equal to 9. So x minus 2 plus 6 is equal to 9. So that says that x plus 4 is equal to 9. So x must be what? X must be 5. Hey, there it is. 5, 1, and 2. Oh, wait. 5, 1, and 3. Sorry. Oh, wow. 5, 2, and 3. That's what I meant. 5, 2, and 3. And that verifies exactly what the calculator gave us way up there. Hey, there it is. There it is. Hey, I got claps. Nice.